All right, welcome to this video. It's on indoor air pollution, and one of the things you want to keep in mind when we're watching indoor air pollution here is that this is especially bad for human health, in that if we're trapped inside the building, right, that has the air pollution in it, and we're in there for a significant period of our time, whether we're sleeping or we're eating or we're just inside, it's our work, we're working there. At any rate, it's bad because you're constantly exposed to it and you're kind of stuck there. And if it's not circulating, the air is not circulating, it can be even worse. Notorious in developing countries, especially because we use a lot of wood for heating and for cooking in these countries, and that wood, when it burns, is usually going to put off soot and smoke, and this would be an example of some really fine particulates that could get into your lungs. So some sources, a lot of different places this can come from. If you've got pets in the home, pet dander can cause allergic reactions, but even if you're not allergic to it, it's still getting into your lungs and your body's having to deal with it. Pollen's another big one, especially this time of the year. Food, while you're cooking, you might have a vent fan above your stove to get those chemicals and the smoke from the food out of your face and hopefully out of the house. Other things that can leave it are VOCs. These are volatile organic compounds. The plastics in carpets and upholstery can turn into the gas phase. And when they turn into the gas phase, that can have potentially harmful chemicals in them. And we kind of like the smell of new cars. It smells great, but it's smelling that way because of these volatile organic compounds that are coming off of it. Sick building syndrome is what can happen in new buildings, and so recently we're trying to cut costs in these buildings by reducing air circulation. Air circulation is important because it gets kind of any pollutants inside the building outside of the building. But if you're paying a lot of money for energy to heat or to cool this building, if you're circulating and you're putting a lot of that freshly heated or freshly cooled air outside, you're kind of losing out on that money you spent bringing it to the right temperature. And so it's kind of this delicate balance. What is enough circulation? What's too much circulation? Some issues that can come with it is the reason why it's called sick building syndrome is because everybody in the building kind of has an array of symptoms and are calling in sick, and the work's not getting done. And it can be due to these circulation problems, but these are all the symptoms that are possible from it. One of these kind of notorious ones is there was a case where Chinese drywall was imported, and so the drywall is typically made from the ash left behind from coal production. So China burns a lot of coal, they've got a lot of ash, they can make a lot of this drywall. Problem is they don't have a lot of precipitation of sulfur dioxide, SO2, from their coal burning power plants, and coupled with the fact that they burn a lot of bituminous coal, which has a lot of sulfur dioxide in it to begin with. The drywall they were producing had a lot of sulfur dioxide in it. It wasn't properly made, and so it was leaking out and causing the sick building syndrome to happen, right? Sulfur dioxide, respiratory problems, along with eye conditions and stuff like that. So it's a case with these newer buildings, particularly where the circulation's reduced. Some common indoor air pollutants. The big four to be aware of are cigarette smoke. Check out the list over here on the right side of the screen. What you've got are all of the things, chemicals that are typically found within cigarettes. And then on this side, we've got common uses. So where are they commonly used outside of cigarettes? And so, for example, carbon monoxide, we're burning this and we're not having enough oxygen. We can produce some carbon monoxide. We know from our lab that comes out of car exhausts. And if you look at something like arsenic, which is found in these cigarettes, that's something we also use in rat poison. So pretty strong array of chemicals and uses here to go with them to kind of put you off of smoking. Formaldehyde, radon, and small particulates we'll talk about in a little bit. First one of those is formaldehyde. And so formaldehyde is used in production of this particle board, and it's a chemical that's used to help preserve and maintain the wood. Particle board is made of all these kind of loose wood chips, and they're pressed and compact and squeezed together, and they mix some chemicals in there to keep them as they are and stuck together. And so when you have a lot of this, or if you're burning it, right, if you're burning a fire in your backyard or something like that, and you're burning particle board, you're releasing this formaldehyde. It can also kind of seep out naturally as it breaks down over time. But there's a couple problems that come with it. Formaldehyde's what they preserve the dead animals with for dissections in labs, right? So it's a really good preserver of organic tissue, but seeing as how we're alive, we're trying to avoid being preserved. Radon. This is one that's not as big of an issue in Florida, but it is something worth mentioning because it will probably be on the exam. And so radon gas, particularly radon 222, this is its atomic mass. And this gas is found or is created from the radioactive decay of uranium, which is naturally found in granite bedrock. And so if you've got bedrock down below, it's going to produce radon gas in very small amounts over a period of time. The difficult thing with radon is this mass is really heavy. The majority of our atmosphere is made out of nitrogen gas, N2, which has an atomic mass of about 28 AMU. So you can see just how heavy radon is. This heavier molecules get stuck in people's lungs, right? So if you picture a person, and we'll put some lungs in this person here. So here's their mouth, and we'll call that their lungs, right? Very healthy, big set of lungs. When the radon gets into their lungs, it's going to fill up the very bottom layer of the lungs. And because it's so heavy, every time you exhale, you're exhaling that air on top, up and out, not the radon gas. And we can't ever exhale all the air out of our lungs. And so it stays in there and it kind of builds up. And radon is radioactive. It's going to emit radiation, which will lead to cancer. And you're keeping those particles right in your lungs, which are very sensitive. So it's pretty bad for your health. It can come in through a multitude of different ways. Typically, we're talking about cracks in the concrete of the home that's allowing air to move in. But there's a couple different ways that it can move in. Big problem in basements because these are going to be lower than the surface of the ground. And so because they're lower than the surface of the ground, that heavier radon can accumulate just like it does in your lungs in the bottom of the basement and build up over time. Air pollution and health. It's an interesting graph to look at. What we have in the red are indoor air pollution diseases, and in the blue we've got outdoor air pollution diseases. And the red line is kind of an overall trend based on population. And so the big areas for indoor air pollution, you can see India, Sub-Saharan Africa, China, Asia and the Pacific, and the Middle East. These are our developing countries, and we talked about this. This is because they're typically burning wood for heating and for cooking, and burning wood in the home without good circulation is asking for a lot of air pollution to build up, and they spend a lot of time in there, and so it kind of builds up over time. You'll notice China's line here is pretty big on both. We have pretty poor regulation of industrial pollution there, which is why their outdoor air pollution is so high, and then indoor air pollution as well. I would assume that in China and India too, they probably are a lot higher percentage of smokers than we have in the industrialized countries, and so that's why they get so much of the outdoor and indoor. We can defend against this, right? Our body's designed to be able to bring in stuff that is harmful to us and kind of prevent it from harming us. And so we've got cilia. These are in the nose and throat and the esophagus and down respiratory system. And what they do is they act like little hairs that kind of catch and filter out the particulates that you're breathing in. These would be like our fine and ultrafine particulates. And when they get stuck to these, mucus will build up over time, and we can cough out or swallow that mucus down and kind of clear out our lungs that way. If we're exposed to pollutants a long time, however, we can break them down, and so over time they'll kind of wear out and not be as effective. And so a lot of these long-term diseases or disabilities here are common to have a lot of coughing to go with it. And so our body is still trying to force out that mucus, although it's not being produced and the cilia aren't trapping what they need to be trapping. The Clean Air Act is an important couple things the Clean Air Act did. Number one is it set health-based standards for ambient air quality and deadlines to achieve them. The important thing to note is that these are the 6 different pollutants that are listed on the Clean Air Act. Notably missing is carbon dioxide. And so what this has is we've got a primary would be like a human health concern. A secondary would be like a secondary concern, like we're going to damage crops or we're going to harm wetlands or something like that. And you've got the duration of exposure here in this column, and then how much concentration is allowed, and then kind of how often that's allowed. And so for carbon monoxide, an 8-hour exposure of 9 ppms or more is thought to be hazardous to your health. All of these are based off of human health standards. And if you were exposed to that, the person that was exposing you to it, it was a company that was creating that pollution or something, or you were at work while you were exposed to that, that company would be subject to fines and stuff like that. We also are targeting large sources of air pollution like cars and trains and power plants and businesses and stuff like that. And those ones have to follow these NAAQS here, is what they're called. National Ambient Air Quality Standards are the NAAQS. The Clean Air Act also designated 187 hazardous pollutants, so air pollutants that are strictly deemed as hazardous and cannot be released whatsoever. And then we also created a cap and trade program for sulfur dioxide to limit acid rain. And so some ways we can improve this in the past or in the future, one of them would be to focus more on prevention. So rather than cleaning up problems and setting this is our limit, let's get as close to it as we can. And then if we exceed it, we'll pay the fine. Let's just prevent it from being released in the first place. We can increase the mile per gallon standards of CAFE. We can regulate 2-cycle engines, these like lawnmowers, weed whackers, things like that, that are not regulated, and they usually burn oil with the gasoline, and so they produce a lot more air pollutants than others. Ocean-going ships, like our big cargo ships, are registered outside the country, and so they don't fall under the American Clean Air Act. We can regulate the greenhouse gas carbon dioxide. This would be a very big step forward if we could do that, or have better enforcement. And so this is indoor air pollution along with the Clean Air Act. Thank you for taking a minute to watch it. And please bring questions and be prepared to discuss tomorrow. Thank you.